everybody. This is the 3.5 video. So we're going to jump in and do a couple of things in 3.5. So the first thing that I'd like to do is have you turn to page 4 of your packet, page 4, and we're going to do a quick review of some things that we've already talked about. So I'm down at the bottom of page 4. These are basic logarithmic equations. We're going to go ahead and solve these because our focus today is going to be on solving more complicated logarithmic equations. So we're going to start here. These are all pretty easy. So here we go. Solving these logarithmic equations. So we remember that really important thing, 4 to the second equals x, so x must be 16. So the answer to the first question is 16. Next, same idea. We're going to do exactly the same thing. X to the third is 64, so x equals 4. These are problems we've done before. We've thought about these, talked about these. Not tough at all, just kind of a warm-up. Get us thinking logarithmically. 3 to the negative second equals x. 3 to the negative second means 1 over 3 squared. So the answer to that one is 1/9. Now be careful here. Remember that the symbol log stands for log base 10. So even if you don't see a 10, there's a 10 there. 10 to the x equals 1,000. So x must be 3. 3 to the x equals 81. So x must be 4. And yes, you are supposed to know that 3 to the 4th is 81. Now this one's got a couple of issues. One of the issues is that we don't even see a base here. So let's rewrite that with a base, log base e, and then we can say e to the x equals the square root of e. Now, I don't really care for radicals in logarithm land, so I'm going to take out that radical and replace it with e to the 1/2. The square root is the 1/2 power. So if e to the x equals e to the 1/2, then x must equal 1/2. Now, while I'm here, I just want to remind you that there are other ways to do these problems. You could, for example, on this problem that we just finished, that looked like this is the way the problem looked, you could think of this as, right here from the beginning, you could think of this as log base e of e to the 1/2. Square root of e is e to the 1/2. The base of ln is e. So log base e, e to the 1/2, the answer would just be 1/2. Same thing we did it the other way. You can always do the problems both ways. Now I want you to turn it over. The back side of problem 4, or page 4, the back side of page 4, and we're going to look at some logarithmic equations using the properties of logarithms that we talked about in the lesson before this. So we have the log base 4, x plus 2 minus log base 4, 3 equals 2. Now we're going to solve this equation. Now, when you had an equation that looked like this one, right here, it's an equation with logarithms in it. It's just a simpler version than that one. When you had an equation that looked like this, you knew that you could rewrite it like this and then solve it from there. We would love to rewrite this. The problem is there are 2 of these, and you cannot have 2 logarithms on the same side of the equation. So these two have to be put together. Now, how are they going to be put together? Well, we talked about this in the last lesson. The logarithms are being subtracted. When the logarithms are subtracted, it means the numbers have been divided. So if you're going to put these two together in one logarithm, if this is going to be condensed into one logarithmic expression, that becomes a division. Because when logarithms are subtracted, the numbers are divided. That is one of our properties. That property says the log base b of m minus the log base b of n equals the log base b of m over n. And it goes both directions. When I wrote this property before, maybe I used different letters. Maybe there's different letters in the book. It doesn't matter. What's important is the concept. When logarithms are subtracted, you can put it together into one logarithm by turning it into a division problem. As soon as you do that, then it looks more like this. Now, it's still more complicated, but it fits that pattern better. So 10 to the x is 1,000. So 4 to the second is x plus 2 over 3. So 16 equals x plus 2 over 3. Sorry about that. Sorry. Wish that didn't happen. Sometimes it does. Okay. So we've got 4 to the second equals x plus 2 over 3. So 16 equals x plus 2 over 3. Let's multiply by 3. And the answer to the problem is 46. Not too bad. Let's look at number 2. I'm still on the back side of page 4. All right, so we got the log base 6 of x. Oh, we got a lot of logarithms floating around in this one. Okay, so lots of things happening. But again, you cannot do the problem, finish the problem, if you have more than one logarithm on either side. So these two logarithms have got to be put together. You have to write this as the log base 6 of something. They have to be put together. And similarly, these are going to have to be put together. Okay? Now, how are we going to put these together? Not as a division. Did you notice that's a plus sign? When logarithms are added, the numbers are multiplied. So if I'm going to put these two together, that's not going to go together as an x divided by 3. It's going to go together as an x times 3. When logarithms are added, the numbers are when logarithms are added, the numbers are multiplied. So we're going to multiply the 3 and the x. So instead of having two separate logarithms added together, I have one logarithm of a product. I'm going to do the same thing over here, only these will go together as a division. The problem is this guy. He's an issue. I can't put my logarithms together if there's that coefficient out in front. So I have to do something with that coefficient. What do I do with it? Well, we've talked about this too. That coefficient was originally a power. Remember, when you take the logarithm of something to a power, you can pull the power off. Well, I'm taking the logarithm of 4 squared. I'm going to pull that 2 off. Now I'm going to put it back. So that becomes the log base 6 of 4 squared, which is 16. So this 2 goes back into its exponent location. Anytime you have a number out in front of a logarithm, it represents an exponent. So you can put it back as an exponent, which is what I need to do. As soon as I do that, then I can take these 2 logarithms and put them together. And when I put them together, they become a division problem. So instead of having a logarithm minus a logarithm, I will have 1 logarithm, and it's a division problem. Just like over here, I have 1 logarithm, but because that's a plus, it's a multiplication problem. All right, let's look at this. This is a little different than what happened over here. What happened over here was I put everything together, got it all cleaned up, but then I only had a logarithm on one side of the equation. So I had to translate it. 4 squared equals this. This is different. There is a logarithm on both sides. This is actually easier if you think about it. The log of red equals the log of green. The log of red is the same as the log of green. Doesn't it make sense then that whatever red is must be equal to whatever green is? Some kids will say, I'm going to drop the logs. Absolutely, you can drop the logs. Now, you can't drop the logs back at the beginning of the problem. You can't drop the logs in this problem. The only time you can drop the logs is when you have the log of red equal to the log of green. Then you can drop those out and solve the resulting equation. So x equals 16/15. Problem number 3 is exactly the same type of problem, but it's not an equation. It is simply asking you to take that big, long expression and combine it into 1. So ultimately, we want to have the log of something, 1 logarithm. We got to put all that together so that it's 1 log. Instead of log, 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 it's 1 log. So think about what we've done in the last couple of problems. Is this bothering you? It should be. I can't start putting stuff together if I have these numbers out in front. So what do we do with those numbers? Well, remember, coefficients in front of logarithms represent powers. So this is the log of x to the 4th minus the log of 2 cubed, and then plus the log of 7. Now, we can start putting stuff together now. See that minus sign? That means something is going to be divided. See that plus sign? That means something is going to get multiplied. So I am going to put all this together into 1 fraction. So I have my x to the 4th. Now it's minus the log of 8. That's the log of 8. So it's minus the log of 8. So that means I'm going to divide by 8. And it's plus, that means I'm going to multiply the log of 7. So I end up with the log of 7x to the 4th over 8. Think about that now for a minute. Don't be confused. Don't be overwhelmed. Think about it for a minute. If you were going to split this up, remember, multiplications become additions. So this would be the log of 7 plus the log of x to the 4th. The log of 7 plus the log of x to the 4th. And then divisions become subtractions. So I'd have the log of 7 plus the log of x to the 4th minus the log of 8. This is the same as this. Number 4 is completely the same idea, but it is set up differently. Okay, so here's the given. That's what we're starting with. And then here's the question. Now, I would suggest that before you start getting all confused and blah, 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 stop. Let's break this up. In other words, let's do the opposite of what we just did here. Here we started with this big spread out thing, and we put it all together so it was one term. Well, this is one term. Let's spread it out, okay? So you should see a multiplication right here. So that's going to be the log base b of 3 plus the log base b of b. This is a multiplication. When I split it apart, it becomes an addition. Just like when it was an addition and I put it together, it became a multiplication. So I've taken care of my top. It's the log of this plus the log of this. Now, that's a division. So I'm going to subtract the log base b of 2. So I have taken the problem apart. The log of 3 plus the log of b minus the log of 2. Now at this point, we're going to start filling in some numbers, because remember in the given, they told me that the log base b of 3 was 0.2. So this is just 0.2. That was given. Made up, completely made up, but that was the given. And this is 0.1. Now, this one they didn't give me. But this goes back to something we've already talked about. In fact, we talked about it in person. The log base b of b to the 1st. That's what this is. This is the log base b of b to the 1st. The log base b of b to the 1st is just 1. Kids, you have a property that says the log base b of b to the nth is n. Always and forever. You're supposed to know that. Nobody's ever going to tell you that. You're supposed to know it. So if I have the log base b of b to the 1st, that will be 1. Just like if I had the log base 7 of 7 to the 5th, that would be 5. So the answer here looks like, I'm just going to add up those numbers now, it looks like I get 1.1 as the answer to the question. So again, that problem looked different, and we did have a little bit of extra step in there. But the bottom line was, the essential of the problem was, you were taking this and breaking it apart. The opposite of what we did here, where we took this and smushed it together. Okay, look at page 5. We're going to practice some of the same thing on page 5. Okay, so everybody's on page 5. Here we go. We're solving a logarithmic equation. So you are looking at this problem, and I know some of you are already writing, because some of you have looked at it and said, oh my gosh, Mrs. Ford said that I needed to have no more than one logarithm on either side. Well, shooty tooty, there are 2 logarithms over here. Remember, ln is log base c. So everything you do with log, you can do with ln. Don't let that confuse you. It's log base c. There are two of them over here. They have to be put together. This side is good. This side only has one, and that's wonderful. One is good. One is great. One is awesome. Two is bad. Very bad. So we're going to take these two, and we're going to put them together. Now, when you put them together, kids, you're either going to put them together as a multiplication or as a division. That's how you're putting them together. It's the only way to put them together. Well, since they're added, they'll go together as a multiplication. So this will be ln 22. When logarithms are added, we put them together as a multiplication. Now look at what you've got. You've got the logarithm of red equal to the logarithm of green. If log red equals log green, then red equals green. So 3x minus 5 equals 22. 3x equals 27, and x equals 9. Number 2. Logarithms all over the place. Way too many logarithms. Very bad news. So we're going to have to put some together. So these two, here's the equal sign. So let's focus over here. We got to get these two put together. So this is going to go together as one logarithm. Now, your choices again are put them together as a times, put them together as a division. Well, how do you know which one to do? Well, you look at this sign right here. If that's a plus, they're going together as a multiplication. So this is going to become the log of 6x minus 2. I multiplied these two things together so that I could write one logarithm. Over here, I will do exactly the same thing. I'm going to write one logarithm. I'm going to put the 4 and the x plus 2 together. I'm either going to put them together as a division or as a multiplication. Since that's a plus, they're going together as a multiplication. So this is going to be the log of 4x plus 8. So these two logarithms got put together as a times. These two logarithms got put together as a times. Now what do I have? Look at the problem. I have the log of green equal to the log of red. And anytime log green equals log red, then green equals red. So if I did it right, I got x equal to 5. And that's the answer to the question. Luckily, there are a couple more. So look at number 3. Now, don't panic that there's no base listed on this. If it makes you feel better, go ahead and put a base 10 on there, because that's what LOG stands for. LOG stands for base 10. You don't have to do that, but you can if you want. Okay? So I'm looking at my problem, and I know right away I need to take care of something. There are two logarithms here, kids, and you cannot do the problem with two logarithms on the same side of the equation. You like having one logarithm on each side. That's wonderful. That is the best possible scenario. But having two over here is bad. So they have to go together. They're going to go together as one expression. These two logarithms are going to be put together as one. And when you put them together, you will put them together as a multiplication or as a division. There aren't any other choices. You're either going to multiply or you're going to divide. Okay, so which is it? Well, this guy right here is the clue. Those logarithms are being subtracted. So we're going to divide. So x plus 9 over x. We're going to write this as one logarithm, and the quantity will be that divided by that because that's a minus sign. Now, this is not what I just had. What I just had was log green equals log red. I could drop out the logs and I'm done. I do not have that situation here. You cannot drop the logs. You only have one. And if you're going to drop them, you have to have one on each side. I don't. So I'm going to translate this into its exponent form. When I only have one logarithm, I translate it into its exponent form. So 10 to the first equals x plus 9 over x. 10 to the first equals x plus 9 over x. So 10 equals x plus 9 over x. 10x equals x plus 9. 9x equals 9 and x equals 1 is the answer to the question. Number 4. I've got logarithms all over the place. We know one logarithm's fine, two logarithms is not fine. So I know I'm going to have to be putting some stuff together, but before I do that, there's something else that has to be taken care of. Do you see it? Yeah, it's these things. They can't be there. We have to get rid of those things. So we're going to move those into their exponent position. Remember, coefficients in front of logarithms represent exponents. Sometimes we pull them off and write them out in front, and sometimes we take them from out front and put them back as exponents. So when we're solving equations, we cannot have those numbers out there. So this is going to become ln 2 cubed plus ln x to the 1/2 equals ln 4 squared. Now, I'm going to go ahead and simplify that. So I say ln 8 plus ln root x equals ln 16. Remember, x to the 1/2 is the square root of x. Now, this side over here is great. There's one logarithm. It's fine. Nothing wrong with it. This side is an issue because it can't have two logarithms. So I'm going to have to put those together as one. Now, how is that going to go together? Remember, it only goes together as a times or a divide. Since that's a plus, these two numbers are going to go together as a multiply. Guess what? ln green equals ln red. If ln green equals ln red, I don't do any translating like I did over there. I don't need to do any of this stuff. If ln green equals ln red, I can drop those logarithms, and 8 root x equals 16. So root x equals 2. If I divide both sides by 8. Squaring both sides, x equals 4. And there we go. Okay? All right. Good deal. Now, we're going to look at this bonus down here. And then we're going to look at a couple in your book that are just like this. Okay, so let's look at this for a second. Now these can be a little bit scary when you look at them. But if you got to be open-minded about it, and you have to put on your thinking cap. All right? And you have to see the big picture and not freak out because it's just relax and look at the big picture. This equation is actually in quadratic form. Believe it or not, this equation is the same as 3m squared plus 11m minus 4. It is the same as that, believe it or not. Talk about why in a minute. But if this were the equation and the directions say factor, then you would set up two parentheses and you would factor this. I'm doing a quick double check to make sure I got that right. That's 12m minus m. Yes, I'm foiling. I foil to check. And there we go. It's factored. And then you would go on to say m equals 1/3 or m equals -4. And that's first year algebra. Easy. So how does that relate to this? Well, what I have done when I rewrote my problem like this, what I did was I replaced e to the x with m. I said, okay, that e to the x is scary, so I'm going to think of that as a single letter, m, or a, or whatever letter you want, c, it doesn't matter, some letter. I'm going to think of that, instead of e to the x, I'm going to think of that as m. Because this guy is the same as e to the x squared. Look at that. Isn't e to the 2x the same as e to the x squared? Remember, you multiply the exponents. So, if I let m be e to the x, or let e to the x be m, then e to the x squared would be m squared. And these two equations are exactly the same. I just used a substitution. I replaced the letter. I said, I'm going to let m be e to the x. Now, what does that mean? I know the directions say don't solve, but we're going to go ahead and solve. What does that mean in terms of the answer? Well, we went ahead and did that substitution, worked out the problem, first year algebra. Easy, easy, easy. But remember, m was e to the x. So what this really says is e to the x is 1/3, and e to the x is -4. Because we took out the e to the x and put in m, because that made it easier to do the problem. Got the problem done. And we got these answers, but they were in terms of m. So now I'm going to substitute back in and say, okay, but m is really e to the x. So e to the x is a third, and e to the x is -4. So now I'm at this point, and my job is to figure out what x is. I gotta, what is x? Think back a few days. When we did a word problem, or 2 or 3 or 4, and we ran into situations where we had something to the x power. And we needed to solve for that. Do you remember what we did? If you're saying we took the logarithm of both sides, you're right. And since this problem has an e in it, I'm going to ln both sides. And the happy news is log base e to the x is just x. So x equals ln 1/3, which I can type in on my calculator. And ln 1/3 is -1.0986. I don't know what the rounding is, but that's close enough. Okay? Now what about this one? Well, it's the same thing. So we'll take ln both sides. So x equals ln -4. All right, so ln -4. Uh-oh. Oh, yeah. Remember we have that domain issue with the logarithms. X has to be big, when we have y equals ln x has to be bigger than 0. We can't do this. There is no solution. And if you think about it, it makes sense. Because can you take a positive number, e is 2.718. If you take a positive number and raise it to a power, will it ever be negative? No, no, that's an extraneous root. The only answer is right here. Okay? Now, I know that's a lot. I know it's a little confusing. So let's look on page 331 of our textbook, page 331, and I'd like to look at number 29. So we're on page 331, and we're doing problem 29. Okay, now wait, you're thinking, whoa, 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 where's that coming from? Well, hang on. Let's get rid of the 3 first. So 2 to the x minus 2 to the negative x equals 12. So that's a little better. Still not very good. I still don't like the way that looks. And one of the things that's really bothering me about it is that negative exponent. So what can I do with a negative exponent? Well, I can rewrite it as 1 over 2 to the x. Whoops, that's a minus. Now, what do you think we might do? I think we will multiply everything by 2 to the x to get rid of the denominator. So we'll just multiply everything by 2 to the x. So I'm going to end up with 2, now watch it, it's 2 to the x times 2 to the x. That's 2 to the 2x. Remember, you add the exponent, so x plus x, 2x. So I have 2 to the 2x minus 1 equals 12 times 2 to the x. Do not multiply those together. That's 12 times 2 to the x. Now I'm going to get it set equal to 0, and I'm hopeful that you will see a similarity to the problem that we just did, that I just erased. I'm going to let m be 2 to the x. So if I do that, if m is 2 to the x, then I will have m squared, because that's 2 to the x twice. So I have m squared minus 12m minus 1. What kind of an equation is that? Well, that's a quadratic equation. Oh, crud. It doesn't factor, it doesn't factor. So I'm going to have to do my quadratic formula. So there's my quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to come out to be, okay, let's see, square root of 148. Now, I need to actually get a couple decimals here. So I'm going to go ahead and type those in and get a couple decimals. So 12 plus the square root of 148 divided by 2, that's about 12.08. And then I'll do 12 minus the square root of 148 divided by 2, and that's negative 0.08. Now those are m values. Remember, we didn't like the way that equation looked. So we let m be 2 to the x. So 2 to the x is 12.08, and 2 to the x is negative 0.08. Does that bother you? Can you raise 2 to a power and get a negative number? Extraneous, just like the last time. We have an extraneous one. This one, however, we can do. How will we solve that? Look where your variable is. How will we solve that? We'll take the logarithm of both sides. So x log 2 equals log 12.08. Got out of room. X will equal the log of 12.08 divided by the log of 2. So I will type that in on my calculator. Log 12.08 divided by the log of 2. And I get an answer, 3.59. Okay, I'm a little long. I got class waiting for me out in the hallway. So I'm going to stop here, and the next video will begin, I'll begin with another example just like this. But these are hard, no question about it. Feel free, back up, replay, back up, replay, until the steps start making sense. But I will do another one just like this in the next video. Hope you're having a great day.